What if, suddenly, the Earth stopped spinning? Not slowly, but completely. The result would be far stranger and more violent than most people imagine. Right now, Earth spins once every 24 hours. At the equator, that spin corresponds to about 1,670 kilometers per hour, approximately 465 meters per second. That rotational motion stores enormous kinetic energy. Stopping it instantly is physically implausible. But, as a thought experiment, it shows how central rotation is to life, weather, and geology. Seconds, minutes. If rotation ceased abruptly, inertia would fling anything not anchored solidly to the crust eastward at high speed. Vehicles, unsecured structures, trees, even loose topsoil and the atmosphere would surge. Expect supersonic winds, global shock waves, and near-instant structural collapse in many regions. Sudden load changes would trigger massive earthquakes and widespread volcanic eruptions as the crust responds. Hours, first day. The atmosphere would reorganize violently. The Coriolis forces that shape jet streams and storm systems would vanish, producing radically different wind patterns. Tsunamis generated by displaced water and seismic events would travel across ocean basins. Initial temperature changes would begin, but the deepest oceans and Earth's internal heat would still buffer immediate freezing. Days, weeks, two important geometric effects appear. First, the tiny centrifugal acceleration at the equator, approximately 0.034 meters per second squared, currently makes Earth slightly oblate. The equator bulges by roughly approximately 21 kilometers compared with the poles. Without rotation, water would slowly migrate away from the equator toward higher latitudes, causing massive long-term changes to coastlines and sea level regionally. Second, without daily spin, the sun's cycle would change. A fixed spot on Earth would no longer see a 24-hour day. Instead, as Earth continues its orbit around the sun, one hemisphere would experience prolonged daylight for months, while the opposite hemisphere endures prolonged night. Roughly months of continuous day, months of continuous night. That creates extreme heating on the day side and intense cooling on the night side. Weeks, months, years. Photosynthesis would collapse across regions in long night, threatening crops and ecosystems. Surface oceans would begin to freeze from the top in cold zones, but Earth's internal heat keeps deep oceans liquid for a long time. Over months and years, continental weather regimes reorganize. Some regions become deserts, others flood. Redistribution of mass causes ongoing tectonic adjustment, sustained seismicity, and volcanism. The Moon-Earth tidal relationship and the long-term dynamics of the system would evolve in response. This scenario is essentially a thought experiment. There is no known realistic physical mechanism that would stop Earth's rotation suddenly. Quantitative outcomes, exact sea level shifts, temperature maps, require full climate, ocean, and solid Earth modeling. Here we highlight robust qualitative consequences supported by physics, inertia, loss of Coriolis effects, mass redistribution, and extreme day-night cycles. Rotation is not a trivial detail. It sculpts our climate, stabilizes weather, shapes ocean currents, and even the planet's shape. If the spin stopped, Earth would remain a planet, but not one hospitable to life as we know it. It's a vivid reminder. Some planetary properties we take for granted are essential to the fragile balance that makes Earth livable.